some other technologies like human-machine interface, user experience, graphical user interface, virtual reality, and augmented reality. In this order, we will start with the human-machine interface. If we need a definition for human-machine interface, if we need a definition, a human-machine interface is a user interface or dashboard that connects a person to a machine, a system, or device. Human-machine interface is an interface. It's something that connects a human with a machine. The machine can be a simple machine like our cell phone, our mobile phone, our television, or a more complex machine like a system in a facility, a very big facility in the industries. While the term can be applied to any screen that allows the user to interact with the device, it is most commonly used for industrial purposes in industrial facilities. Human-machine interfaces are building screens on machines, computer monitors, and tablets. You can see an animated picture here where we provide insight into the performance of a machine, and we can see the facility and the operations that happen each time, being able to monitor temperature, pressure, the tank levels, and anything we need, and everything we have in our facility. This is an example of the plant floor, operator. So we can push the buttons and interact with the machines through the facility, through the human-machine interface. I just like we use the air conditioning system in our house. If we push the buttons, we can change its temperature or up and lower. We can change humidity and unique things. And a simple example of an HMI we try to explain. We can take the simple example of a car, which is a complex machine, but we can operate the car through the not the human-machine interface. Nowadays, we almost have HMIs in cars, but we think that we have several parts of the car, like the steering, the lights, the air conditioning, the stereo, and various other elements. These parts of the car are operated by the buttons and the instruments we have in our hands. So if we have all these things operated by, controlled by a digital screen, we could have a human-machine interface to operate the different parts of the car through this device. So if we have a bigger facility in an industry, for example, like in this animated picture, we can use HMIs to interact with the machines and optimize their several industrial processes. In this picture, you can see HMIs connected to several elements of the industry, of the certain industry. We have RTUs and VLCs, we will discuss about this later. And there are HMIs, which are technology to control interfaces, to control the machines which are far away from where the human is. A person sits in the desk or is in a room, and through the HMI can control devices and other machines that are far away from where he or she is. This happens in many industries like energy, food and beverage, manufacturing, oil and gas, power, recycling, transportation, water and wastewater, and many more industries already. I don't know if there is some industry that does not already use HMI and could use HMI. I think there is a wide acceptance of this technology already. And the people who use HMIs, the professionals who use HMIs for their work, are operators, system integrators, engineers, and particularly control system engineers. HMIs for those people are essential resources for these professionals, and they use HMIs to review and monitor processes, diagnose problems, and visualize data. Let me say that through the presentation, I'm trying to give I'm trying to give a job-oriented approach, which means I'm trying to focus on professions or jobs someone can do by using what we will discuss about today. So if someone is an engineer or an operator, we are talking probably about someone who uses an HMI. So maybe if you like HMIs, you may become an operator. Of course, you have to have studied engineering or something to get to the facility the HMI operates, but you might also as well become a person who designs and creates HMIs. So if you understand that HMIs is a technology that we use everywhere, maybe you can think of how would a good HMI be designed, and maybe you can become an HMI designer. We will see this potentially later, but let's focus on the purpose of HMIs. HMIs are sometimes are similar to graphical user interfaces, and sometimes people confuse them, but they are not the same. They are not synonymous. Graphical user interfaces only show images, pictures, or something. But HMIs are connected to devices, and they show us data coming from these devices. So we use HMI to visually display data. Data is another section of this project. You will talk about that and their importance in technology these days. So we use HMI to visually display data, to track production time, trends, and tags, to oversee key performance indicators, to monitor machine inputs and outputs, and many more. In this picture, you can see a professional HMI user, let me say. It's a person who uses the HMI to operate the facility, this big facility in front of him. So he can monitor several indicators related to the machines that are into that big facility. without having to walk to these machines. You can see the pressure of the tank without having to go in front of the tank and write down the pressure. This makes it easier to make decisions and saves time and energy, of course, and we can also avoid the human mistakes. To take a better look at what exactly HMIs do, let me just in short say that they communicate with the PLCs. The PLCs are programmable logic controllers. They're the tangible part of the system. PLCs have inputs and outputs. Let's say PLCs count things and they show the numbers they count to the HMI system. HMIs can be simple. For example, they can just monitor the temperature they can just monitor the temperature of a tank, or they can be more sophisticated, do more complex things like turn on and off machines, or depending on the temperature, increase or decrease pressure or something we program them to do. But in general, they are used to optimize the industrial process. We use them for being able to more quick and easier and in a better and more safe and secure way, have a general view of the facility, of the operations we want to accomplish, and do that all through one console. So if we have all the systems united and connected to one console, there is no need that we have a person who has to go to the facility, which may be even far away from where the offices are. The person doesn't have to go to the facility and monitor and write down the values and the inputs and outputs, and they come back, calculate, and decide which at which time of the day something has to happen. So this can save us from many problems that are almost automated. Another system that is usually connected with HMI is the SCADA system. It is the supervisory control and data acquisition system. Sometimes this is also confused with the HMI. And in fact, an HMI is often a part of the SCADA system. If you see in the picture, the SCADA system just controls a large system. It combines PLC, sensor, and RTUs, remote terminal units. It collects and records data, but in the SCADA system, we did not do operations which we can do through the HMI. So the SCADA system monitors, collects the data, records the data, and shows us the data. And we use the HMI system to push the buttons and do the action based on the data we see. So this is the difference between these two systems. The SCADA system collects and records data, while the HMI is the interface that someone uses to interact with the system and other systems and equipment. I will try to be short and not bomb you with information. HMIs and SCADAs are both essential elements of larger industrial control system. You can see here a bigger SCADA system which collects and stores data. What we can understand is that the system depends on the facility. A bigger facility will have a bigger SCADA system. If we have 10 tanks in our facility, we should have 10 tanks in our SCADA system. So we are trying to overview our equipment and monitor the data, collect and store the data in real time, so that we can use this data and make decisions and change things through the HMI. This in a smaller scale is done in our house also. We have an HMI, which is a screen in our phone, an application in our phone. We collect data, for example, from our air conditioning system. And if we see that the temperature is high or low, we push a button and we send information to the machine to change something, increase or decrease temperature. So they are both connected, confused sometimes, but they are different things. The SCADA works in the background. The HMI is in front, and it is the element we interact with. And of course, the final decision is mostly human, but there are HMIs that make decisions by themselves if we program them to do so. Another difference between HMI and SCADA systems. HMIs are focused on visually conveying information to help the user supervise an industrial process. SCADA systems have a greater capacity for data collection and control system operation. Unlike SCADA systems, HMIs do not collect and record information or connect to databases, but rather provide an effective communication tool that functions as part of a SCADA system. You can see the difference. I think the difference is maybe the difference is already obvious and understood. Some more information. HMIs are used in manufacturing, from automobiles, food and beverage, and pharmaceuticals to industries such as energy, water, wastewater, buildings, and transportation. They are used in system integrators, operators, and engineers. And while the sophistication of the HMI varies according to the complexity of the machine or system and how we plan to use the HMI. The benefits from HMI are enhanced visibility, where when we have a high performance HMI, you can see how our equipment is performing from a single dashboard. We almost already discussed the benefits. There is increased efficiency by having constant access to real-time data. If we combine data analysis technologies, which are very popular nowadays, with data visualization, we can find areas to improve the efficiency of operations. We also can have decreased downtime using HMIs, improve usability and unification of the system. We have all the control of all equipment in one platform, so it is easier for us to learn how to control the equipment. We can view all the data at one time in one location, so we can have a clear overview of the facility. This almost happens nowadays in smart homes. We can view all the data of the facility in one screen, which is maybe our mobile phone or a tablet or the screen of our office laptop. So there are several benefits from HMIs. There are also several types of HMIs. This is an HMI in a touch screen and mobile device. This is an HMI in a touch screen. What we just discussed. The HMIs in mobile phones can give us the flexibility and the availability of anytime, anywhere I can see the temperature or the data I need to see in my mobile phone. I can do changes. I can, instead of having buttons and the switches, operators in my house, I have my touch screen. We even change channel in our television through our mobile phone. This had to happen, for this to happen earlier, in earlier years, we had to get up and walk to the television and push the button. This was there. After that, we had the remote control, and now we can also touch the screen in our phone. Another type of HMI is high performance HMIs, which are used to see critical indicators and respond to problems more efficiently. They give much attention in details and use graphics and controls to optimize the user experience. They have many much detail in the information they provide. Remote monitoring, we already discussed. An engineer can be in anywhere in the planet, maybe, and they can check and control the temperature of the facility or anything else the machine needs to be controlled. So there's less need for working hours and presence in the facility. Edge of network and cloud HMIs. I think we talked about the Internet of Things in the previous bootcamp. So nowadays, the Internet of Things, the collection of big data. We have devices that collect data, and through the edge layer, excuse me, we upload data in the cloud layer, and anyone who has access to the data can perform operations remotely, while the control of the facility remains local. You have the local facility, this big factory. Thank you. This big factory there. And by collecting data and uploading them to the cloud, you can control the operations in the factory from anywhere. The future of HMI, some interesting bullet points to remember. The data is for sure taking a more prominent role in industrial processes. We have high performance HMIs. We can connect them with big, huge amounts of data we collect every day from anywhere. Companies are using more and more multi-touch screens, remote monitoring, and cloud-based systems. And technologies like advanced data analytics and artificial intelligence can help us make connections and derive insights from data and communicate these results to users through the HMIs. Automation has a central role in industrial processes, and in the future, HMIs may also incorporate augmented reality and virtual reality technologies, which we will discuss later. So these are all things to think about, to think if we can work on them. Study, for example, study data analytics and artificial intelligence and try to find an interesting way to collect data from a facility and make an insight for something, depending on the creativity and the interest of each of us and you and our viewers from far away. So in this short video, we will see.
Welcome to another informative video from Real Parts. Today, you'll learn all about HMIs.
It's something like a revision of the HMIs.
Before starting this video, I want that you encounter them pretty regularly. Welcome to another informative video from Real Parts. Today, maybe you've never heard of an HMI, but I'll bet you encounter them pretty regularly. HMI is short for Human-Machine Interface. We use HMIs in industry to control and monitor machines. A very common HMI that you all encounter on a regular basis would be an ATM machine. The screen and push buttons allow you to operate the machine to dispense a certain amount of money or to deposit money. Let's talk about industrial HMIs now. It would be hard to have a good automated process in industry without an HMI. Many times, an HMI will be in the form of a screen, kind of like a computer screen, and more times than not, they are touchscreen. An operator or maintenance personnel can operate and monitor the machine from the HMI. It may include information like temperature, pressure, process steps, and material counts. They can also show very precise levels in tanks and exact positioning of the machines. Where machine information used to be viewed on multiple indicators, it can now be viewed on one screen. The possibilities are only limited to the software and hardware used. For maintenance personnel, many HMIs can also connect to PLC logic and display it on the screen for troubleshooting purposes. This can save valuable time compared to connecting a computer or laptop every time. Another benefit of having a modern HMI is the fact that plants and other industrial sites can monitor and control multiple machines or other equipment. A small manufacturing facility could even monitor the entire plant on one centrally located HMI. Water and wastewater facilities have utilized this for years by coupling an HMI with a PLC. They are able to monitor remote locations like water pumps, as well as equipment inside the plant. You probably get the idea now that an HMI is the operating panel and monitoring screen. But how does the HMI actually connect to the machine to be able to control and monitor it. Let's take a look. First, HMIs use special software so engineers can program them correctly. Different brands of panels use different software accordingly. Software allows the engineer to design what the operator will actually see on the screen, what they can monitor on the screen, what buttons can be pushed, and how the operator can manipulate the machine. For example, an HMI may have a large tank displayed on the screen with the level of a liquid displayed. Next to the tank is a pump to lower the liquid level. An HMI can also have the start and stop button displayed and usable on the screen next to the pump. This display would be able to actually turn the pump on and off. But it's not as easy as just placing a button on the screen or a tank with a level on the screen. The person programming the HMI has to program each indicator and button to a specific input or output address of a PLC. This brings up another point. The HMI and PLC need to be compatible. This means they need to be able to talk to each other. They do this on what's called a protocol. Different companies use different protocols. Company protocols are Modbus, Ethernet IP, and Profibus. These are all just industrial networks, kind of like the network you may have in your home with multiple computers, TVs, or other devices connected to each other. Industrial protocols connect the different PLCs, HMIs, and other machines to each other. Protocol information is easily found on each manufacturer's website. Once the PLC and the HMI are talking, then whatever is programmed into the HMI can be used to monitor and control PLC functions. Let's review. Today, you've learned some of the basics of an HMI, or human-machine interface. These are the monitors and controls of a machine that allows the operator to run a machine or monitor a machine. Engineers can program an HMI to perform almost any function that can be controlled, or information that can be monitored by a PLC. HMIs and PLCs work together to monitor and control the machine. This means they have to be compatible, and they also have to speak the same language, so to speak. This comes in the form of a protocol, which is just an industrial network. Please stay tuned for another informative video from Real Parts.
This is a review of the HMIs, different protocols, connect devices. We program the screen, we push the button to the screen, the message goes to the device through the protocol, and we have the function of the machine. So, the next, I will be glad to